Greetings to all viewers. This is Professor Ankit Singh. We'll now move to the next type of numerical, that is numerical on overtaking side distance. Okay, let us have a look at the question. The speeds of overtaking and overtaken vehicles are 70 kmph and 40 kmph respectively on a two-way traffic road. The average acceleration during overtaking may be assumed as 0.99 meter per second square. We need to calculate first A. Calculate safe overtaking side distance. B. What is the minimum length of overtaking zone? And C. Draw a neat sketch of the overtaking zone and show the positions of the signposts. Okay. So this is the question. We'll now move to the solution. So the overtaking speed capital V has been given 70 kmph and overtaken speed is 40 kmph. So we convert these speeds into meter per second because our acceleration value has been given in meter per second square. Okay. So in order to convert from kmph to meter per second, we divide the values by 3.6. So dividing 70 by 3.6 we get 19.4 and 40 by 3.6 we get 11.1 meter per second. Now the formula for overtaking side distance for two-way traffic is OHD is equal to D1 plus D2 plus D3, where D1 is VB into small t, D2 is VB into capital T plus 2s, and D3 is capital V into capital T. Okay. Now the value of small t, that is the reaction time, we assume it as 2 seconds, that is standard as per IRC. Okay. For OHD. For OHD we need to consider a reaction time of 2 seconds. Now D1 equal to VB into small t, the value of VB is 11.1 into 2 will give us 22.2 meters. Now for D2 there is a term S. Okay, we need to find out this. So there's a formula S equal to 0.7 VB plus 6. We substitute the value of VB as 11.1 and solving we get the value of S as 13.8 meters. Now there's one more term, capital T. Okay, the formula is given as root of 4s by a. We just found out the value of s, we substitute it here and we know the value of a, that is acceleration, given in the question 0.99 meter per second square. Solving this we get 7.47 seconds. Now we can substitute the values of s and t and find out the d2. Okay, so it would be 11.1 into 7.47 plus 2 into 13.8. Value of D2 is 10.5 meters. D3 is capital V into capital T. Capital V is 19.4 meter per second and capital T is 7.47 seconds. So solving this we get 144.9 meters. So now we have the values of D1 plus D2 plus D3. Okay. So summing these values we get the total OHD for two-way traffic, that is 277.6, which is almost equal to 278. Okay. Now the next thing to find out was minimum length of overtaking zone. Okay, the formula for which is 3 into OHD. Okay, and the desirable length of overtaking zone is 5 into OHD. So we have already found out the value of OHD. So minimum would be 3 into OHD. 3 into 278 would give us 834. Desirable is 5 into 278, 1390 meters. Okay. So in the third we had to draw the overtaking zones and also draw the signposts and mention the values. Okay. So this is the diagram for this. So minimum overtaking zone length is 834 and desirable is 1390. Okay. There is a signpost SP1 here and SP2 here for this direction, and from this direction SP1 here and SP2 here. Okay. The distance from the overtaking zone would be equal to OHD. Okay, OHD is 278, so this is 278. Okay, this is 278, this is 278, and this is 278. Now what do these signposts mean? SP1, SP2. Okay, SP1 means signpost which displays overtaking zone ahead, and SP2 is signpost which displays end of overtaking zone. Okay, so we'll now move to the next question, that is on super elevation, a numerical on super elevation. The radius of a horizontal circular curve is 100 meters. The design speed is 50 kmph and the design coefficient of lateral friction is 0.15. Calculate the super elevation required if full lateral friction is assumed to develop. Okay, this is the first condition. Second condition, calculate the coefficient of friction needed if no super elevation is provided. Okay, so we'll go ahead with the solution. What is given to us? Velocity, design speed is given, so 50 kmph. Radius of horizontal curve is 100 meters and coefficient of friction is 0.15. For the first condition, okay, we know the formula for super elevation is E plus F equal to V square by 127 R. Okay, here it is said that super elevation is required for if full friction is developed. Okay, so we need to find out E when friction is 0.15. So we substitute the values of V and F and we solve to get the value of E as 0.047. Okay, this is the super elevation value. In the second condition, it is said that no super elevation exists. We need to find out the coefficient of friction. So in the same formula, you just substitute E equal to 0. In that case, F would be equal to V square by 127 R. Okay, V is 50, so 50 square divided by 127 into R is 100. And solving this, you will get 0.19. Okay, so we'll go ahead with the next problem. This is a problem on super elevation design. A two-lane road with design speed 80 kmph has horizontal curve of radius 480 meters. Design the rate of super elevation for mixed traffic. By how much should the outer edges of the pavement be raised with respect to the inner edge if the width of the pavement at the horizontal curve is 7.5 meters? Okay, so what is given to us? Design speed 80 kmph, radius of horizontal curve 480 meters and width of the road at the curve is P, that is 7.5 meters. Now since it is given that it is a mixed traffic condition, okay, so for mixed traffic condition the super elevation should fully counteract the centrifugal force for 75% of the design speed. Okay, so instead of counteracting the 100% design speed, we counteract 75% design speed. Okay, so in the formula E plus F equal to V square by 127 R, when you substitute 0.75 V here instead of V, you get this formula. Okay, this I have already discussed in the theory classes. So the formula is E equal to V square by 225 R. Substitute the value of V, that is 80 kmph, and R, that is 480. You get the value 0.059. Okay, now since this value is less than the maximum super elevation value, that is 0.07, we can adopt this value. So super elevation of 0.059 is adopted. Now given in the question that the width of the road is 7.5 meters, we need to find out the by how much do we need to raise the outer edge of the road with respect to the inner edge. Okay, so the formula is capital E equal to B into E. Okay, so capital E is the value that we need to raise. Okay, so we know B, it is given in question 7.5, and E we just found out 0.059. So we get the answer 0.44 meters. Okay, we'll now move ahead with the next problem. The design speed of a highway is 80 kmph. There is a horizontal curve of radius 200 meters on a certain locality. Safe limit of transverse coefficient of friction is 0.15. Then there are two conditions. Calculate the super elevation required to maintain this speed first, and second, if the maximum super elevation of 0.07 is not to be exceeded, calculate the maximum allowable speed on this horizontal curve, as it is not possible to increase the radius. Okay, so let us see what is the given. Design speed v is equal to 80 kmph, radius of horizontal curve 200 meters, and coefficient of friction 0.15. So we follow the same design steps. First step is E equal to v square by 225 r. Substitute the value of v and r here. Okay, v is 80 kmph and r is 200 meters. We get the value 0.142. Now this 0.142 exceeds the maximum super elevation value 0.07. Okay, hence we do not adopt this value, and we continue with, and we limit the super elevation value to 0.07, and we move to step 2 where we check for friction. Okay, so check for value of friction developed with design speed and E equal to 0.07. So we have the formula F equal to v square by 127r minus E. So E we have taken 0.07. Substitute the value of v and r over here. So 80 and 200. So we get the value 0.18. Okay, but now again this value is also greater than 0.15, that is the maximum F value given in the question. Okay, so what we do is, now again we adopt the maximum value F equal to 0.15. Now since the radius of curve cannot be increased, the speed has to be restricted. We have no other choice. Okay, so now determine the maximum allowable speed, that is VA. We have the formula VA equal to root of 27.94 into r. R is 200 radius. Okay, so we get the speed 74.75 kmph. This is the restricted speed. Hence the speed may be restricted to less than 74.75 kmph at this curve. Okay, so next is a numerical on radius of horizontal curve. I'll continue with this in my next class. Thank you.